In this tutorial, you will learn class members are variables and methods that belong to a class rather than individual instances of a class. You will learn to use the static keyword to create class members, and you will learn constants are defined using the static keyword. You will learn which combination of instance and class, variables, and methods are allowed. When a number of objects are created from the same class blueprint, they each have their own distinct copies of instance variables. In this case, the box class, the instance variables are length, width, and height. Each box object has its own values for these variables stored in different memory locations. This statement creates a box object with 1 by 1 by 1 dimensions. This statement creates a 2 by 2 by 3 box. Each box object contains its own copy of the non-static instance variables and non-static methods. Sometimes you want to have variables that are common to all the objects. This is accomplished with the static modifier. Variables that have a static modifier in their declaration are called static fields or class variables. They are associated with the class rather than with any object. Every instance of the class shares a class variable, which is one fixed location in memory. Any object can change the value of a class variable, but class variables can also be manipulated without creating an instance of a class. For example, suppose we want to create a number of box objects and assign each an ID beginning with 1 for the first object. This ID number is unique to each object and therefore is an instance variable. At the same time, we need a variable to keep track of how many box objects have been created so that we know what ID to assign to the next one. Such a variable is not related to any object but to the class as a whole. For this, we need a class variable, numBoxes, and we will modify our constructor code to increment this variable and assign the value to the box object. When B1 is created, the constructor code will increment the class variable numBoxes and assign the value to the object's ID variable. Now numBoxes contains 1, the number of boxes that have been created so far, and our first box object has an ID of 1. When B2 is created, numBoxes is incremented to 2, and this value is assigned to the box's ID variable. Class variables are referenced by the class name itself, as in this statement, box.numBoxes. This makes it clear that they are class variables. You will not reference class variables through a particular object. Java supports static methods as well as static variables. A common use for static methods is to access static variables. For example, we could add a static method to the box class to access the numBoxes static variable. Static methods which have the static modifier in their declarations should be invoked with the class name, without the need for creating an instance of a class, as in this statement, box.getNumBoxes. It is possible to invoke static methods with an object reference like b2.getNumBoxes, but this is discouraged because it doesn't make it clear that they are class methods. So let's modify our box class to add the class variables and methods. We'll add an integer variable ID so that each instance of the box class can have its own ID number. This statement creates a static member called numBoxes, which is assigned an initial value of 0. This is a class member, meaning that only one copy will be created in memory for all objects to share. Let's modify our box constructor to increment the numBoxes class variable and assign that value to each object's ID variable. So every time we say new box, numBoxes will be incremented and that value will be assigned to that object's ID variable. We'll add a static method, getNumBoxes, to return the value in the numBoxes variable. When creating static methods within the class, those methods cannot access any non-static data. So in this getNumBoxes, I could not access the variables length, width, and height since this method only exists within the class, not within any instance of the class. The static modifier in combination with the final modifier is also used to define constants. The final modifier indicates that the value of this variable cannot change. For example, the following variable declaration defines a constant named pi, whose value is an approximation of pi, which is the ratio of the circumference of a circle to its diameter. Constants defined in this way cannot be reassigned, and it is a compile time error if your program tries to do so. By convention, the names of constant values are spelled in uppercase letters, and if the name is composed of more than one word, the words are separated by an underscore. Not all combination of instance and class variables and methods are allowed. Instance methods can access instance variables and instance methods directly. Instance methods can access class variables and class methods directly. Class methods, those marked with static, can access class variables and class methods directly. And class methods cannot access instance variables or instance methods directly. They must use an object reference. Also, class methods cannot use the this keyword, as there is no instance for this to refer to. In this tutorial, you learned that class members are variables and methods that belong to a class, rather than individual instances of a class. You learned how to use the static keyword to create class members, and you learned constants are defined using the static keyword. You learned which combination of instance and class variables and methods are allowed.